All right, the unit circle recap. So here is a completed unit circle, and in calculus, it's not going away. You're going to have to use the unit circle because you're not going to have times where you have a calculator to calculate the sine of 2 pi over 3 or the cosine of pi over 4. You're going to need to kind of regurgitate the unit circle in your mind, particularly in quadrant 1 mostly, but you should be able to understand the whole unit circle. So let's kind of do a quick recap. So let's start with the degrees. So we know the degrees are 0, and we know it's going to end up at 360, right? So we know this must be half, 180, and then this must be 90, and this must be 45. And then how do you know the other ones? I already know it's 30, 45, 60, but how do you know what these are? So how I think about it is if I know this is 90, these are thirds, right? So what's a third of 90? This is 30 degrees, and then another 30 is 60 degrees. So that's how I remember it. Okay, so let's move on to the radians. Okay, so we know we have 0 radians here, and a 2 pi is a full circle. So if a full circle is 2 pi, what's half a circle? Must be half of that 2 pi, right? So this is 1 pi. Most people just put pi, but I'll just do 1 pi for now. And then you can do the next one. What's half of that 1 pi? It's half a pi, right? So I'll just do 1 over 2 pi, or pi over 2. They mean the same thing. Okay, so kind of like that thirds idea, what's a third of pi over 2? Pi over 6. And then another 1, if this is 1 pi over 6, the same slice over one more of that is just pi over 6 plus another pi over 6, which is 2 pi over 6, which simplifies to pi over 3 or 1 pi over 3. So 1 pi over 3. And so you can do this same idea for the rest of the circle. This is pi over 6, 2 pi over 6. What's another third right here? 3 pi over 6. Hey, 3 6 is 1 half. That makes sense. 1 6, 2 6, 3 pi over 6. 4 pi over 6. Can we reduce that? Yes. 4 pi over 6 is 2 pi over 3. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Do you see how we're doing that? And so you can do the same thing with this middle one right here. So let me just clean this up a little bit. So what about this middle one right here? What's that going to be? Well, I know the full 90 degrees right here is 1 half pi. So what's half of that? Pi over 4. 1 pi over 4. So we can use that same technique, and we can go 1 pi over 4, 2 pi over 4, which makes sense. Here's the next one, 3 pi over 4, 4 pi over 4, that makes sense, 5 pi over 4. So that's how I remember the radians of the unit circle. Okay, so now let's figure out what the coordinate pairs are in here. So clearly the easiest ones are the corners, right? So what is this corner right here? It's a horizontal distance, an x value of 1, and how much in the y? 0. How about this one? It doesn't move horizontally, it's 0, and then it moves up 1. So what about these three? How do we figure those out? So I don't like memorizing. I like to remember and understand the conceptual reasons why the unit circle is the way it is. And so I will show you using triangles. So let's talk about this triangle right here. So this, if that's a right angle, what's the angles on this guy? 30. This is 30. Then this is 60. And that's 90. And we know that the hypotenuse is 1. And so what is the horizontal and the vertical distance? If the hypotenuse is 1, then we know the short side, using the special right triangles, has to be half of the hypotenuse. And then we know the long side has to be 1/2 times root 3, or root 3 over 2. So what's my x and y coordinate right here? My x coordinate is the long side, root 3 over 2, and then my height is 1/2. Hey, that's nice. So then that's it. Now, if we know this, then we know this. Why? Because this is the same exact triangle, except now this is 60 degrees and that's 30 degrees. So what do you think the coordinates are going to do here? They're just going to flip. 1/2 here and root 3 over 2 there. And you have almost the complete picture of these coordinate pairs. So what's this final one? Well, we know this triangle right here is a 45, 45, 90 triangle, and a hypotenuse of 1. So if I use Pythagorean, I know some value, I'll just call the length a squared plus a squared equals 1 squared. Why is that? Well, if that's a and that's also a, because they're the same, right? Same angles mean same sides. So that's why you have a squared plus a squared equals 1 squared. And so that turns into 2a squared equals 1. So that means a squared has to equal 1/2. And if I do the square root, then I get the square root of 1 over the square root of 2, which is just 1 over square root of 2. And that's a perfectly good answer. But most people don't like radicals on the bottom. So what you'll do is you'll multiply top and bottom by root 2. And so what ends up happening is you get 1 times root 2 on the top, which is just root 2. And what's root 2 times root 2? Isn't it root 4? And what is the square root of 4? 2. So that's how you get square root of 2 over 2 and square root of 2 over 2. So now you can see some patterns here, that all of these guys have 2 as a denominator. And I know that there is this weird but very cool 1, 2, 3, and 1, 2, 3. And so basically, depending on how you think about it, it's up to you which one is the 1, 2, 3 and the 1, 2, 3. You don't want to mix these guys up, right? You don't want to switch this one and put it here, because that'll make it all messed up. So how I remember it is I kind of do a geometrical thinking. I go, okay, which one of these is the 1/2? Which one of these is the root 3 over 2? And I just look at the triangle here, right? Now, which one of these looks like 1/2? Well, I know this whole thing is 1, right? So what looks like the half of that? Right here. That's why I know the y value is 1/2 here. That's how I think of it. You have your own methods, but there you have it. The unit circle in the first quadrant, and you can use those same ideas for the rest of them, but these are the most important ones. And so the final piece I want to talk about is how do we do the sine, cosine, tangent if we do know the unit circle. So just to remind you, whenever they ask for the sine, they are asking for the y value. When they ask for the cosine, they're asking for the x value. And when they ask for the tangent, they're asking for the y divided by the x. So what's the sine of 2 pi over 3? Well, we haven't done it here, 2 pi over 3, but I know there's a symmetry between these two. And so it must have the same y value, but the x value is the same, but probably in just a negative version because that's on the left side. So it's asking the sine of 2 pi over 3. Sine has to do with y, so that's this value. Root 3 over 2 is your answer. And so how do we do the cosine of pi over 2? Well, here's cosine of pi over 2 right there. And so cosine is the x value, and there you go, the answer is 0. Tangent of 5 pi over 4 is way down here. We haven't done the coordinates, but you know all the corner ones, the 45-degree angles, have a root 2 over 2. So root 2 over 2, root 2 over 2. Now, are they negative or positive? Well, they're going left and down, so they're both negative. So what's tangent? Y over x. So it's negative root 2 over 2 divided by negative root 2 over 2. And they're the same value, so we know it's positive 1. And there you go, a basic unit circle, how to do these individual parts.